You probably have heard of OpenTelemetry. You understand the concept, but it seems that you're looking for a video explaining how to instrument your code. So if you're trying to instrument your code utilizing OpenTelemetry, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide a tutorial on how to observe a given technology. Today's episode is part of an existing series, the OpenTelemetry series, where we already had an episode explaining and introducing the concept, the tooling, and more related to OpenTelemetry. We also did one dedicated episode to a technology that has been recently donated to the OpenTelemetry community. It's the SQL commenter. Today, we will be focused on how to instrument your code utilizing OpenTelemetry. This episode is covered in two distinct parts. Part 1, sharing best practices related to instrumentation. Part 2, delivering a technical tutorial where we would show how to instrument your code, mixing manual and automated instrumentation library. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode, the part 2 of OpenTelemetry. So first, we will see the core object of the OpenTelemetry library. Then we will see how to attach your automated instrumentation library to your application. We will share a few concepts related to manual instrumentation. And last, we will jump into a tutorial where we will instrument the hipster shop. Most of the language of the market has their own OpenTelemetry library, but all the languages follow the same process. Step 1, you will send your telemetry to an observability backend. So you can either send it directly to your backend of your choice using the existing available protocol like Jaeger, Zipkin, or OpenTelemetry HTTP or gRPC. Or you can also use a proprietary exporter that will interact with your backend of your choice. Keep in mind, you can utilize the OpenTelemetry collector that will avoid instrumenting your code with any proprietary library or exporters. So at the end of the day, your application will send your measurements to the OpenTelemetry collector, and the collector will push the data to your observability backend of your choice. In any case, using the OpenTelemetry collector or not, you will have to define what we call a trace provider. That trace provider will be the core concept of the instrumentation. So next, once you have defined the exporter and your provider, you will need to define a span processor. And there are several types of span processor available. There is the simple span processor that will immediately forward ended spans to the exporter. Then you have the batch span processor that batch the end spans and send them to the exporter in bulk. We have the multi-span processor, allowing multi-span processors to be active and configured at the same time. If you're looking for real-time traces, then you will have to utilize the simple span processor. But for most of our observability use cases, the batch span processor is usually making a great job. Step 3, then there is a big potential that we need to define resources. So the resource will be sent to the processor and will be adding extra context to our spans. So we can add, for example, the service name, the service type, the version, and way more. Last, you need to define a sampler. It will control the number of samples of trace that will be sent to your backend. And there are several samplers available. So we have the always on sampler, which samples every trace regardless to the upstream sampling decision. We have the always off, which doesn't sample any trace regardless to the upstream sampling decision. We have the parent-based, which use the parent spans to make sampling decisions. And then we have the trace ID ratio-based, which sample a percentage of traces. So the sampler is very important. You will probably first use the always on to generate traces and then find the right sampler. Because at the end we need enough details, but we don't want to pay too much in terms of storage. Because if you send too many traces, then of course you need extra storage to store all those traces. Like explained in the part 1 of this episode, adding automated tracing to your application requires to attach an agent. Of course, depending on the language, the approach will be slightly different. So let's see how to add the library on several languages, starting with Java. Java will be in fact the most simple one. To add automated tracing library to your application, we attach an instrumentation agent to the JVM using the -Java agent option, and we will add a couple of system properties to configure the agent on how and where it will send the spans. The Java agent has several environment variables that will help you to, like mentioned, configure the exporter. So you will have probably one exporter per type of signal. So for the logs, for the traces, the metrics. We can add extra resource information. We can customize the span processor. We can also customize the sampler as well. So here is the link to the GitHub repository of the Java agent. The Java agent supports various types of exporters. And to enable your exporters, you will have to precise hotel, traces, and exporter, and precise the type. So you can have hotel metrics, exporter, and the type, and so on. And for each OpenTelemetry exporter that you've defined, you will have specific environment variables to configure the endpoint, the port, and so on and so forth. So by default, it supports OpenTelemetry, so HTTP or gRPC. So if you enable the traces on OpenTelemetry, you will also have to precise the environment variable related to OpenTelemetry, so the hotel exporter traces endpoint. You can also define the other type of exporters like Jaeger. So if you define it, you will have to precise that the trace exporter is a Jaeger, and you will have to configure, similar to the OpenTelemetry, the endpoint of your Jaeger server. If you don't define the environment variables for Jaeger or even for OpenTelemetry, in fact, it will utilize by default the local host. So in the case of Jaeger, it will be local host on the port of Jaeger, which is 14,250. Then you have, of course, the support of Zipkin. So you have to precise that your exporter is on a Zipkin format, and similar to Jaeger or similar to OpenTelemetry, there are specific variables that will help you to configure the Zipkin endpoint. And if you don't specify any values, it will utilize localhost, of course. And out of Zipkin, Jaeger, and OpenTelemetry, the Java agent supports as well other exporters. We have the Prometheus exporters for metrics, and we also have the logging exporters, which is at the moment in alpha version. So here, for example, we're launching a Java application. So we precise a couple of Java options like the memory, the application name, the home path of the application, and then all the various variables to enable the automated instrumentation library. So here we utilize the Jaeger protocol. We have a specific Jaeger endpoint, and you will have to match to the path of your Java agent. C#. In case of C#, you will need to add the right NuGet package to your project. And at the start of your application, you will have to initialize the trace provider and attach various instrumentation libraries. So for example, here we have an example where we attach the ASP.NET Core instrumentation. We also attach the HTTP client instrumentation, the gRPC client instrumentation, and because we're using in our case Redis, there is a specific Redis instrumentation. So for each of your library, make sure that you also add the right instrumentation library that you need to properly have the right level of instrumentation. So in the case of C#, you will have to add few lines of code to enable your instrumentation. Node.js. So similar to C#, Node.js will require to import the right libraries. You will need a library for your exporter. So here we import the OpenTelemetry trace exporter. And then you also need to import the right span processor of your choice. So here we import the batch span processor. And if you need to add extra resources, you will have also to import the resource library. And in any case, like we mentioned, we need a trace provider, so you will have to import the Node.js trace provider. Then once all of those library has been imported, don't forget to also import your instrumentation library. So here we have an example where we import the automated Node.js instrumentation library, and you can add as many instrumentation library that you need for your code. Once you have imported those libraries, similar to C#, you will have to define your trace provider, your exporter, your span processor, and then register your instrumentation library to your trace provider. In fact, Python and Go have the similar journey as Node.js. So at the end, import the right packages for your span processor, your sampler, for your resources, for your trace provider, for your exporter, and all the instrumentation library. And then of course you will have to initialize your trace provider, add the exporter to your trace provider, and then attach and register all the various libraries that you need for your instrumentation. Similar to the automated instrumentation library, we will first need to have a tracer configured. Once the tracer object is defined for your service or your application, you will be able to create spans. And the trace provider has the methods that allow you to create spans. So tracer.spanBuilder and the name of your span. Then you can define a kind for that span. It could be a client span, or it could be a server span. And then of course you will have to start your span by utilizing the start span function. Then you will have to end your spans once your process has finished. So don't forget to close all your spans. And if you have exceptions or if you have errors, keep in mind to catch those errors and exceptions to be able to change the status of your spans into error, and of course end the spans just after that. Once you have a span, you will be able to add span attributes, events, having attributes as well. You can also link spans together by defining your parent span. And for that, of course, you need the parent span object to add it to your method. In this tutorial, I will walk through the instrumentation of the hipster shop. All the service has been instrumented utilizing the instrumentation library of each of those languages. We have the Python, we have the Node.js, and we have the Go and Java and C#. In the case of the Java services, which is the add services, I have created few manual spans. So in this tutorial, we will generate traces and export them to an OpenTelemetry collector. The collector will have a simple trace pipeline receiving the generated traces and will export them directly to the Dynatrace trace ingest API. So let's see all the configurations and requirements one by one. In this tutorial, we will need first a Kubernetes cluster with 2-3 nodes. We need a Prometheus operator to expose metrics. We will also need an nginx ingress controller to expose our application out of a cluster. Last, to deploy easily the OpenTelemetry collector, I will utilize the OpenTelemetry operator. This operator provides several new CRDs for Kubernetes, and in fact, you will see it simplifies a lot the configuration of your OpenTelemetry pipeline. This project is amazing, and I will clearly create a dedicated episode related to the OpenTelemetry operator.
like every tutorial, like usual, there will be a GitHub repository related to this episode. So this episode is about OpenTelemetry instrumentation. So the idea here, I took the initial online boutique repository of Google and I have already instrumented. So I will walk through the various things that you need to consider when applying the automated instrumentation and the manual. Like I said, you will do only the manual on the Java application, but again, it's possible to do on other services. So I won't go through the deployment of your cluster. You just have to follow the various steps. One thing which is quite important here in this tutorial is that we are going to deploy Prometheus because we are going to run some load through K6. K6 is a load testing solution, and we will do a dedicated episode, by the way, on K6. And K6 will create spans from the load testing virtual user generated by K6. So that will be very nice to see the consequence. We will also use Prometheus again because K6 has a Prometheus exporter. Please follow the various steps to deploy that is here in this tutorial. Everything is described. And one thing which is important here is we are going to use an OpenTelemetry operator. So here is the repository related to the OpenTelemetry operator. I have extracted the various steps to deploy, and you will see, which is quite nice, is that they have a new CRD called OpenTelemetry collector. And this is one of the objects that we will deploy in your cluster with the new pipeline, and with the advantage that you don't have to kill your pods of your collector. Everything is done through an operator, so it's updates, it's smoother, it's easier. We will do an episode on that. Thing which is important, this tutorial relies on Dynatrace, so which means you will have to go to dynatrace.com if you want to test it out. Again, you can connect it to your Observability platform of your choice, but if you don't and you want to just follow the steps, go to dynatrace.com, go to free trial, and free trial you will be able to get a new tenant from a Dynatrace perspective. First, before we do anything, before we jump into the actual instrumentation, let me show just the structure of the repo. So here we have Kubernetes manifests. This is the deployment of the hipster shop with the ingress and so on, because here we will use an ingress to interact with this application. And this hipster shop, I have already pre-built those containers. So if you look at the image names used by this hipster shop release, you see that it's my own Docker Hub repo. Side of that, we have the OpenTelemetry manifests, like I mentioned, where we have an OpenTelemetry pipeline. So all the different services of the hipster shop will push traces and span to the OpenTelemetry collector. When you deploy it, it will. I have chosen the daemon set deployment, but you can do it through a sidecar. But here in my case, deployment is fine, fair enough. The sidecar will allow you to avoid precising the endpoint. You can use local hosts, like we explained. But here, daemon set, you will have to. So there will be a service in the cluster that will be listening for traces. And as you can see here, receiver, we take the OTLP protocol, so we accept gRPC and HTTP. And what we're going to do is going to push on gRPC, and we're going to send over through HTTP to Dynatrace. So there are a few things to do, so follow it, replace your tenant URL. There are a few steps that you need to follow. There is, of course, a Dynatrace API token to be generated. Let me show you again how to generate this API token. So in your Dynatrace tenant, you have access token, and in access token, you would be able to create a new API token. So in our case, we will generate a new API token And the only required rule is ingest metrics, OpenTelemetry traces. But you can also add, if you want to test the metrics ingest and the logs, you should also click on the metrics and the logs ingest. But at least the minimal one is the OpenTelemetry traces. Once you have created that token, keep in mind to store the token somewhere, because you will need to replace the OpenTelemetry collector deployment. All right, so now let's have a look at the various changes that has been made on the various services. So in source, you will see, so here you won't see those two services because I have to adjust it for demo purposes. So don't pay attention on the no hotel. It's the same one, but I have removed all the reference to the OpenTelemetry. As you can see, I have the K6 load generator. So I have a container here to build the K6 image, and I have a predefined script for interacting with the Hipster shop. So let's have a look. Let's start. So in the Hipster shop, there are 11 services, and the 11 services has different type of language. So we have let's start with the cart services. The cart services will be in C#. The ad services will be in Java, and then we will see checkout and the others are in Python and Node.js and Go. So let's start with the cart services, which is C#. So we explained in this episode that first you need to add the import the right packages. So in the cart C# settings, I have imported here few couple of nuggets package. So I have the ASP.NET Core instrumentation, the HTTP instrumentation, the gRPC, because the communication is done through gRPC, and I'll have an exporter with OpenTelemetry, but you can also use the console. So it's to the out if you want to also instrument that. And there is the Redis if you need to instrument also the Redis one. Once those library has been imported, the only change that has been made in this project is on the startup. On the startup of this service, like mentioned in the episode, you will need to initialize your trace provider and attach to them or register to that all your various instrumentation library and your exporter and so on. So here in this particular case, I have added few variables as environment variables. So this is not mandatory, but here in my case, I want to customize the host, the port, and the service name that I want to give to my spans. Those are through variables. So once I have retrieved this, the line that will initialize the tracer and everything is here. Add OpenTelemetry. So it's user builder. As you can see, we adding the source. So this is the source of the source name. We adding the various instrumentation library with Redis as well. And then here we have the console exporter. We don't need to configure something special. And I have added as well here the OpenTelemetry exporter, where I am basically reconstructing through those environment variables the path to our OpenTelemetry collector. Next, let's jump into a service built in Go. So in Go, similar to C#, you need to import the right library. So you'll have to go to Go mod, to import the various required modules. So here I have imported the hotel gRPC instrumentation library. So this is not available on the hotel repo yet. It's on the contrib repo. And then I have included the default libraries of OpenTelemetry on the 1.30 in my case. And I have the exporter in gRPC, as you can see here, and the SDK. Once you have those libraries imported, then you have to go to your main. So in my main, you'll see if you scroll up to the top, you still have the same import. In my case, I've imported hotel, the gRPC, the resource, because I will add some resources, the exporter, and so on. Now, let's see, in my case, I have created a method called init provider. So that will be my provider. I'm similar to the other services. I'm getting the various address and port to interact with the collector. And then, like described in this episode, I initialize a batch span processor, and then once I have everything initialized, the span processor and the exporter. So here you have the auto trace exporter. I've added some resources for the name, the service name, but it's not required. But then once you have the trace provider, then you create a new trace provider and you add your sampler. So here as always sample. You add your span processor, so batch span processor in my case. You add your resources, and then you can also, and that's it. Then once you have this trace provider defined, you define in the hotel instrumentation, it sets the trace provider. That's the only thing I do here is initialize the provider, and you'll see that later on in the start of the service. So in my case, it's the gRPC server. So here I have a new gRPC new server. Here I'm adding the hotel server interceptor and the stream server interceptor. Next is the Node.js services. So let's have a look at the payment services. So the payment services, similar to that, you need to import your library. So I have imported the exporter for gRPC. I have the HTTP, but you don't need it in my case. You need the instrumentation, so global one and gRPC, because it's done through gRPC. And then I have added some resources and semantic conventions. So that is the required libraries. Once those are been defined, what I do, I have added a tracing file here just to initialize the tracing in my main application. So if you go to index, you will see here it is. We are getting our tracing. Let's have a look at the tracing. So the tracing is here, similar to the others and similar to what we explained. You need a trace provider, a batch processor. So here we have you can see we have the trace provider. We have a simple span processor here. We have the various instrumentation library, and then we will register those libraries. So starting, you need to first, I create a registrations of the various instrumentations. So I have the register instrumentation object defined. Then I define my OpenTelemetry exporter, the various configurations that you need. And then here I'm defining the trace provider, where I am also attaching some resource to that. And then with the trace provider defined, I can add my span processor and register everything. And then once you have this, you get the tracer and you can utilize it. That's for Node.js. And now the last one that we didn't cover is Java. To be honest, Java is the most simple. So you can do it with either Maven or Gradle. In my case, I use Gradle. So if you look at the build Gradle, there are a few libraries that has been added similar to the others. So once those libraries are defined, you can go to the source code. So then all the library has been imported. And there are two services in our case, the ad services and the client. And you will see that there are a few things which is pretty great with Java, is that you have annotations with span that you can add. So you don't have to precise. You can just add this and the spans will be added. But in my case, I've added a few spans manually just for the sake of this tutorial. So the first thing you will see, I didn't mention that, but in Gradle, you will see the way it works. At the end, I have adding the Java options with the OpenTelemetry agent, and that's allow me to attach to the application the Java agent. And then the various environment variable, they will be passed through the container environment variables. Now, let's have a look at the service. So the service, in this instrumentation, we didn't do much. As you can see, I am doing the manual instrumentation, so there is nothing defining any tracer or anything. So I don't have to do that. This is done magically with the Java agent. But the only thing I do here, I get the tracer span builder. So I create a new span. Once I have the span, then you can basically start the span, which I do, and then you can end the span like it is. So here there's another. Let's have a look at another one. So here I have a span builder. I set a span kind server. You start the span. So here I have my get span. Then you can set some attributes, some methods here in my case, and add. And you can create some event attributes if you want. And then here in my case, I'm adding a new event, constructing adds using context, and I'm attaching an attribute. Again, like I mentioned, if you have a try catch, which I do here, in the catch, you can see that I have events, so error, precise some events, and I'm putting the spans to error, and I'm ending the span. So make sure to do that for each of your methods. All right, so what I just for information, so make sure that K6 service is running to get some traffic. So here I just, so if it's not running, because the script is run for 24 hours, you may need to restart it. So to start, you delete the pod and you restart it. And it's part of the hipster shop namespace. To get your traces, you will have to go to distributed traces. So here, let's go to the last 30 minutes, yes, and go to ingested traces, because it's traces that we have pushed from the API perspective. So we should see those traces coming in here. Now you can see it's now. So let's take this trace. I may have more traces coming in a few seconds from a user perspective, but here you can see HTTP GET. So this is done by K6. We can look at the spans related to this one. So get connection, for example, we can see that so everything here is still on the K6 side, and then I'm getting to the product. So here I'm moving to one of the services of the hipster shop to the product catalog. You can see get product, get the method get product here. So you get all the details that you're looking for. Then you can see that we're calling the currency. So all the traces are there, and you get, and then you have the last method is received, which is basically K6 receiving our response, and that makes the end of our trace.
So that's it for today's episode related to instrumenting your application utilizing OpenTelemetry. So we covered a few important core objects related to OpenTelemetry, like the span processor, the sampler, and as explained on the part 1 of this episode by Yoshi Yamaguchi, keep in mind that the span processor and the sampler the one that you select could impact the storage of your traces. Alright, so if you enjoyed today's content, don't forget to like and subscribe to the channel, and we will produce more episodes related to OpenTelemetry. Especially, I would like to show the value and all the various options that the OpenTelemetry operator offers. Thank you for watching. See you soon for another episode. Bye.